Hello. Hello and welcome to this exemplified read-through of datetime functions and operators. Now, when we did the data type formatting and pattern matching, I showed you the example before getting into the theory. But this time I will hold on to example. I'll show you quickly. Okay. So, for example, you see this. Okay, we don't need this. Okay. So you see that we have this file which is roughly 400 odd longs, odd lines, 400 odd lines, roughly 477 to be exact. So we will go through this at the end once we have read the theory side of it. Now coming back to the theory side of it, you see it starts at page number 279, goes till 296, roughly 17-18 pages. So it will probably take 4 videos to go through the entire documentation, maybe three, and plus one for the practical side of it. So hold on to your horses and we will do the practical at the end of this theory side of it. So we'll cover the theory first. So that's what I have to say about the introduction of this. So let me send it in full screen so that we have bigger font. So we start with the datetime functions and operators. Now datetime are very crucial and critical part of PostgreSQL or any database because you always want to know when a row was inserted. So usually we have a created date column with almost everything that we want to know when things have changed whenever we do update. So we have updated column. For example, when a user was last logged in, last logged out in a web application. So datetime is very important when particularly when designing the web applications. Okay. So without further ado, let's get started. Table 9.33, that is 33. 33 will be after this. Okay. Shows the available functions for date or time value processing with the details appearing in the following subsections. Table 9.32 illustrates the behaviors of the basic arithmetic operators. Basic arithmetic operators means plus, minus, multiplication and all. Division doesn't make sense. I'm not sure. Is there division? I don't think there will be division. We'll come to it. There is division. For formatting functions, refer to section 9.8, which we have covered. To underscore timestamp function should be familiar with the background information on datetime data types from section 8.5, which also we have covered. In addition, it would be best if you can watch the entire playlist in order. You will see a lot of information here which we have not covered. Which we have covered. And watching the entire playlist in order will show you a lot of practical and theoretical side of this particular playlist. In addition, the usual comparison operators shown in table 9.1 are available for the date or time types. Dates and timestamps with or without time zone are all comparable, while times with or without time zones and intervals can only be compared to other values of the same data type. When comparing a timestamp without time zone to a timestamp with time zone, the former value is assumed to be given in the time zone specified by the time zone configuration parameter and is rotated to UTC for comparison to the latter value, which is already in UTC internally. Similarly, a date value is assumed to represent midnight in the time zone when comparing it to a timestamp. All the functions and operators described below that take time or timestamp inputs actually come in two variants. One that takes time with time zone or timestamp with time zone, and one that takes time without time zone or timestamp without time zone. For brevity, these variants are not shown separately. Also, plus and star operators come in commutative pairs. For example, both date plus integer and integer plus date, we show only one of each such pair. So we have date plus integer, we'll increase the date. Okay. So if you add plus 7 to 28th of September 2001, you will get 5th of October 2001. We have date plus interval, which will give us a timestamp. We can advance this by 1 hour. So from midnight, it will advance to 1 a.m. We have date plus time. So it will also give us a timestamp. You advance the date by that time, you get morning. So whenever we have date, it is assumed to be at midnight, 00:00:00 hours. Then we have interval plus interval, which will give us interval. So 1 day, 1 hour will give 1 day and the interval. Timestamp plus interval will give timestamp. So like this, you get the interval. Then we have plus time plus interval. So adds interval to a time. Minus interval will negate the interval. Date will date minus date will give an integer. So it will be difference in number of days. Date minus integer will give a date. Date minus interval will give a timestamp. So just it's a different, just it is converse of addition. Time minus time will give interval. Time minus interval will give time. Timestamp minus interval will be timestamp. Interval minus interval will be interval. Timestamp minus timestamp will be interval. Now we have multiplication. Interval when multiplied with double precision will give the interval. So for example, interval 1 second multiplied by 900 will give us 15 minutes. Interval 1 day multiplied by 21 minutes will give us 21 days. Interval 1 hour multiplied by 3.5 will give us 3 hours 30 minutes. Then we have interval slash division. So that will yield the interval. 1 hour divided by 1.5 will give us 40 minutes. And then we have table 933 date time functions. Age will take two timestamps and subtracts arguments, producing a symbolic result that uses years and months rather than just days. So if you subtract two timestamps, you'll get interval. If you just give timestamp, subtracts arguments from the current date and you get an interval. Clock underscore timestamp will give us timestamp with time zone. It gives us current date and time. We have current date, which will give us date, current time will give current time. Current time, if supplied with an integer, will give time with time zone. So current time of day with limited precision. Current timestamp will give timestamp with time zone, that is now. Okay, current timestamp with an integer will give us timestamp with time zone. Date add will take timestamp with time zone, interval, and optional text. Gives us timestamp with time zone. Add an interval to a timestamp with time zone. Computing times of day and daylight savings adjustments according to the time zone named by the third argument or the current time zone setting if that is omitted. The form with two arguments is equivalent to timestamp with time zone plus interval operator. So date underscore add, if you take this, you have timestamp with time zone plus 2 and you add 1 day, which is an interval, and we have an optional time zone, we give it that. Then the date will be increased by 1 and then from the time this time zone that would be applied and we have the resulting date. Then we have date underscore bin, which takes interval time and two timestamps, gives us a timestamps. Bin input the specified interval aligned with specified origin. So date bin 15 minutes and we have two timestamps. One is 16 February 20:38:40 hours. And we have another timestamp 16 February 2001 and the hour minute seconds are 25:00. So the output here is 16th of February 20:35:00. Okay. So let me think a bit. Bin input into specified interval aligned with specified origin. It does not say about specified. We'll look at 9.9.3 and it will be clear. Date underscore part will take a text and timestamp and gives double precision, get timestamp subfield equivalent to extract. Then we have example date underscore part. We want to extract hour from the timestamp, we get 20. Date underscore part, it takes, we extract month here. Similarly, we can extract year or day. So a lot of it will be clear when we read this section. We have date underscore subtract, which takes time stamp with time zone and interval and returns timestamp with time zone. It subtracts the interval from the timestamp with time zone, computing times of days and daylight savings adjustment according to the time zone named by the third argument or the current time zone setting if that is omitted. Date underscore truncate to specified precision. For example, we have this and we want to truncate 2 hours, so it will truncate 2 hours. You see that 3840 has been replaced by 00. Then we have date underscore trunc, which takes a timestamp with time zone and a text. So it will take day, it will extract, it will truncate till date, and timestamp is there. So this is the timestamp with time zone, and our target time zone is Australia/Sydney. So it converts this into what you call Australia/Sydney time zone and truncates the hour, minute, second, minutes and second part. Then we have date underscore trunc, text comma interval, so truncates to specified precision. Here we have chosen hour, so 40 minutes are gone. Then we have extract field from timestamp. We can extract hour, month, date, and no, hour and month or second, okay. Then we have is finite date, test for finite date, not plus minus infinity. Is finite timestamp, so if it is infinity, then it is false. Is finite interval, it should not be plus minus infinity if you want true output. And similarly, you can give plus minus infinity to make it false. Justified is adjusts an interval converting 30-day time periods to months. So we have 1 year 65 days, it converts it to 2 months and 5 days. 1 year is preserved. Justify underscore hours does the same thing for hours. So we have interval 50 hours 10 minutes, so 48 hours are converted to days and remaining are left. Justify interval is the same thing. So if you subtract 1 hour from 1 month, you get 29 days and 23 hours. Then we have local time, which is the current time of day. Local time takes an integer current time of day with limited precision. So if you give 0, you miss out on milliseconds. Local timestamp is the same thing as local time, but with time zone. It is without time zone. Local timestamp takes an integer with limited precision. If you give 2, then you get for the milliseconds 2 significant digits. We have make underscore date, which takes year, month, and day as integers. Negative years signify BC, so you can construct a date. We have make interval, which takes years, months, weeks, days, hours, minutes, seconds, and precision. So gives us an interval. Then we have make underscore time, which take hour, minute, and second. So it gives us a timestamp, or time, not timestamp, time. Then we have make underscore timestamp, which takes year, month, day, hour, and all that, and gives us a timestamp. Same make timestamp period, analogous to previous one. It optionally takes time zone and gives you timestamp with some time zone. Then we have now, which we will use a lot, which gives current date and time. Statement underscore timestamp, which gives us timestamp with time zone, which gives us current date and time. Then we have time of day, which gives current date and time, like clock underscore timestamp, but as a text thing. Transaction timestamp, current date and time, start of current transaction. To underscore timestamp, it takes a double precision argument, which gives us timestamp with time zone, which converts unique epoch to timestamp with time zone. So if you give it a double, it will calculate from Unix epoch. Okay. In addition to these functions, the SQL overlaps operator is supported. Start1, end1 overlaps start2, end2. Start1, length1 overlaps start2, length2. This expression yields true when two time periods overlap, false when they do not overlap. The endpoints can be specified as pairs of dates, times or timestamps, or as a date, time or timestamp followed by an interval. When a pair of values is provided, either the start or the end can be written fast. Overlaps automatically takes the earlier value of the pair as the start. Each time period is considered to represent the half-open interval start less than equal to time less than n, unless start and end are equal, in which case it represents that single time instant. This means, for instance, that two time periods with only an endpoint is common do not overlap. So we have some examples here. We select our date is 16th February 2001 to 21st December 2001, and it overlaps with 2001 30th October to 30th October 2002. So yes, there is an overlap between 30th October 2001 to 21st December 2001. It will overlap. And similarly, we have other examples of this. Now, let me see where we are. We are at 285. I don't think it will take 4 or 5 videos. Let's see. Okay, so there are examples and all. Let's see. We will go till this section and then we will end. Okay. Uh, this page we are going to cover. Okay. When adding an interval value to or subtracting an interval value from a timestamp or timestamp with time zone value, the months, days, and microsecond fields of the interval value are handled in turn. First, a non-zero months field advances to decrements the date of the timestamp by the indicated number of months, keeping the day of month the same unless it would be past the end of the new month, in which case the last day of the month is used. For example, March 31 plus 1 month becomes April 30, but March 31 plus 2 months become 31st May. Then the days field advances or decrements the date of the timestamp by the indicated number of days. In both these steps, the local time of the day is kept the same. Finally, if there is a non-zero microsecond field, it is added or subtracted literally. When doing arithmetic on a timestamp with time zone value in a time zone, it recognizes DST. This means that adding or subtracting, say, interval 1 day does not necessarily have the same result as adding or subtracting interval 24 hours. For example, with the session time zone set to America Denver, we have a timestamp and we have an interval 1 day which advances the day. Okay. Now you see here that this hour is different. Okay. Now we do the same, but this time our interval is 24 hours. So you see, this time the hour is now 13 here. Okay. But here the hour was unchanged. So there is a difference because DST change happened during this period. Note that there can be ambiguity in the months field written by age because different months have different numbers of days. PostgreSQL's approach uses the months from the earlier of the two dates when calculating partial months. For example, age 1st of June 2004, 30th April 2004 uses April to yield 1 month 1 day, while using May would yield 1 month 2 days because May has 31 days while April has only 30. Subtraction of dates and timestamps can also be complex. One conceptually simple way to perform subtraction is to convert each value to a number of seconds using extract epoch from, then subtract the results. This produces the number of seconds between the two values. This will adjust for the number of days in each month, time zone changes, and daylight saving time adjustments. Subtraction of date or timestamp values with the minus operator returns the number of days, 24 hours, and hours, minutes, seconds between the values, making the same adjustments. The age function returns year, months, days, and hours, minutes, seconds. Performing field by field subtraction and then adjusting for negative field values. The following queries illustrate the differences in these approaches. The sample results were produced with time zone is equal to US Eastern. There is a daylight saving time change between the two dates used. So we have 1st of July 2013 and we have epoch from timestamp, and here it is given as noon time, and we subtract here the date is 1st of March and noon time. So you get this, I think it is seconds, right? Yeah, seconds. So many seconds from epoch. Then we extract epoch from timestamp and we have 2, and we have subtraction here, so that is that. Then we have select timestamp period, we have timestamp, and then we subtract from other timestamp, we get 121 days, 23 hours. And then we have another example. So please go through, if it is not clear to you again, repeat this section, okay? Go through these 2 sections again and try to understand the examples. If you have a problem understanding it, let me know in the comments and I'll explain it more. So with this, we come to the end of part 1 of date and time. In part 2, we will cover the rest of it. That is tomorrow, we will finish date and time. So, okay. We may not be able to cover it. No, there is a lot of information. It will take 3 videos for sure. So let me look at that. So we finished up to here, 286, and we have to go till 296. 2 more days it will take. Okay. So on the 4th day, we will have the practical side of it. The file which I showed you, we will go through that file. So I hope that you are enjoying this playlist and read through of this PostgreSQL documentation. I hope that you are enjoying the learning and you are able to learn something in this read through. So once again, thank you for watching the video, and we will meet tomorrow with more of documentation read through. So thanks a lot for watching the video. I'll see you in the next one. Till then, keep learning and enjoy.